Okay, so here's some special angles. I mean, I do consider the axes special angles, but here's what they're talking about more about special angles. So building off what we talked about, so we are going to try to find 45 degrees. So if we have the triangle with 45 degrees, now notice that this is 45 degrees, this is 90 degrees, and this is 45 degrees. Okay, so with that, we would have, since these are the same, we could treat this as x as well, and that's what we're showing over here. So you could treat, using Pythagorean identity, that x squared plus y squared is 1. You could say x squared plus x squared is 1, or 2x squared is 1. So x squared is 1/2, so x is plus or minus the square, 1 over the square root of 2, or plus or minus 2, square root of 2 over 2. That's if you rationalize the denominator. So with that, cosine of pi over 4 is, or 45, is square root of 2 over 2, and so is sine of pi over 4. They're the same value. Now in terms of cosine and sine for 30 degrees and 60 degrees, so think about an equilateral triangle and an equal angular triangle. These are all 60-degree angles. Okay. Now if you were to split this triangle into two triangles, as I do here, we get a 30, 60, what's this? 90-degree angle. So this is a very popular triangle, 30, 60, 90 triangle. And we can then relate the sides. Now, if we know that r is, here's our r, sine of pi over 6. So sine of pi over 6, by the way, pi over 6 radians is 30 degrees, and pi over 3 radians is 60 degrees. So what we're going with here is that sine of pi over 6, or sine of 30, is 1/2 r. So it's half of this. So 1/2 of 1, so it's 1/2. So using Pythagorean identity, we can then solve that cosine of pi over 6 is square root of 3 over 2. Because you'd have 1/2 squared plus, I guess, cosine of pi over 6 squared equals 1. So that's 1/4 plus cosine of pi over 6 quantity squared equals 1. So cosine of pi over 6 quantity squared equals 3/4, or cosine of pi over 6 equals plus or minus the square root of 3 over 4. So we would have plus or minus square root of 3 over 2. And this one's not, well, I guess this does show from this diagram up here, first quadrant. Even third quadrant cosine is going to be positive. But we're going with the first quadrant. We're trying to come up with some standard values, so that we could conclude that cosine of pi over 6 is the square root of 3 over 2. And then likewise, I mean, we can keep doing this for trying to find pi over 6 and pi over 3. I have a chart here for you. These are our standard sets of values. So if the angle is 0, cosine of that's 1, sine is 0. If the angle is pi over 6 or 30, remember those are the same, cosine is going to be square root of 3 over 2, and sine is 1/2. If the angle is pi over 4 or 45, because those are the same, 45 degrees, then cosine square root of 2 over 2, sine square root of 2 over 2. If it's pi over 3 or 60, cosine is 1/2, sine is square root of 3 over 2. And if it's pi over 2 or 90, it's 0 or 1. 0 for cosine, 1 for sine. And I want to just tell you something right now. You're going to learn a whole lot of values. And I'll show you in a minute a graph or a drawing with all these values on there. But I want to stress that you're going to learn a lot of values. And if you memorize just this set, you can very quickly derive all the other values from the charts. Okay, so this is an illustration showing you the same thing. So get you the y value. Y values are here, x values are here. Okay. So evaluate cosine of 5 pi over 3 using a calculator or a computer. Well, I mean, you can do that. 5 pi over 3, by the way, if you think about it, like here's pi over 3, here's 2 pi over 3, and then down here it would be 4 pi over 3, and over here is 5 pi over 3. And we're going to get into something called reference angles in a second, but that means it's as if this is pi over 3 here. 5 pi over 3 plus pi over 3 makes that whole circle. So it's really looking like cosine of pi over 3. And as we saw above, that's 1/2. And because the quadrant we're in, it's 1/2. Now you can also put this in the computer and you'll get probably 0.5 as your answer. So, okay, we'll stop with that because our next video is about the domain and range of sine and cosine functions.